Hi, I'm Young from Seoul National University Computer Vision Lab. I will introduce the paper recovering 3D hand mesh sequence from a single blurry image, a new dataset and temporal unfolding, accepted by CVPR 2023. Our main contributions are twofold. First, we present a new dataset, blur hand, contrast to previous 3D hand datasets, which mostly contain sharp images. Our blur hand contains realistic and blurry hand images. Second, we propose a blur-robust 3D hand reconstruction network, Blur HandNet. While most previous 3D hand mesh estimation network produce a single 3D hand from a sharp image, our Blur HandNet produces the sequence of 3D hands. This video shows the qualitative results of our Blur HandNet. Blur HandNet successfully recovers 3D hand motion from a single blurry image. I'll introduce more details about our paper. The blur hand dataset provides diverse and realistic motion blurred hand images. We provide statistic of blur hand. The joint motion magnitude means length of 2D trajectory of each hand joint in a blurry image. This measurement can indicate how large the blur is. As shown in the figure, blur hand contains diverse blur from mild to severe blur. We construct blur hand as shown in this figure. The blur hand is synthesized from Interhand, which is widely adopted video-based 3D hand dataset. Given the 5 sequential images from Interhand, we first apply the video interpolation method to complement the low frame rate of Interhand. Then, we average the sequential frames, including interpolated frames, to synthesize the blurry image. The video interpolation process is necessary as averaging frames from a low frame rate induces unnatural artifacts such as spikes and steps. Considering the construction pipeline of blur hand, our blur hand net produces sequence of 3 hand meshes. The output hand meshes of blur hand net correspond to first, third, and fifth sharp hand respectively. The blur hand net consists of 3 modules, unfolder, kTformer, and regressor. The kTformer stands for Kinematic Temporal Transformer. Given the input image, unfolder predicts the 3D coordinates for 3 time steps. Then, grid sampling is applied to feature map with joint coordinate to form temporal joint features. The temporal joint features from unfolder is fed to the kTformer. kTformer defines temporal joint features by utilizing kinematic and temporal correlation. Finally, the regressor regresses sequence of monoparameters and forward it to monolayers to obtain 3D hand meshes. Let me show the experimental results. We validate the effectiveness of presented blur hand through the experiment that train and test the 3D hand mesh estimation network on interhand and blur hand. Please note that test set of blur hand contain unseen blur from train set of blur hand. The network trained on interhand suffers severe drops for the blur hand. On the other hand, the network trained on blur hand performed well on unseen blurry image. This experimental result demonstrates that training on blur hand is necessary when handling the blurry image. In addition, the network trained on blur hand also performed well on interhand, and it shows generalizability of blur hand to sharp images. We provide a qualitative comparison of real-world blurry images. in YouTube 3D hand datasets. We've trained Blur HandNet on three different combinations of datasets. First, Interhand and YouTube 3D hands. Second, deblurred Blur hand and YouTube 3D hands. Third, Blur hand and YouTube 3D hands. As shown in this figure, employing Blur hand for the training produced the most robust 3D hand meshes. We validate the effectiveness of proposed unfolder and K-former through our ablation study. While solely employing one-up unfolder or K-former shows a slight improvement over the baseline networks, Blur HandNet results in great performance boost by benefiting from the combination of two modules. These results demonstrate that each module effectively complements each other. Interestingly, using unfolder and K-former does not bring performance gain when training and testing on deblurred Blur hand. This is because deblurring prohibits network from utilizing temporal information. Figure in the right side shows attention map calculated from the K-former. The attention map indicates that temporal information is highly preferred to compensate for insufficient joint information in a certain time step. We provide qualitative comparison with state-of-the-art 3D hand mesh estimation method. As the previous method do not have special modules to address blurs, they fail to produce accurate 3D meshes from blurry hand images. On the contrary, our blur hand net produces much better results than previous method on blur hand. In this paper, we focus on hands with blur artifact. However, various types of image degradations are prevalent in real world, such as low resolution, noise, and low illumination. Below figure shows that our blur hand net produces less accurate results when input contain multiple complex degradation. Robust 3D hand mesh estimation framework to complex degradation will be considered in our future works. Thank you for watching the video. You can access our paper and code through the QR code. And please refer to the following links for more details.